Good, sir. How are you?
I'm also fine. Okay. Wait 1 or 2 minutes so that the other student may also join. Okay.
Okay.
Okay, Rima. So what we are studying in the previous class? Today is actually Rima. Are you there?
Yes, sir. Yeah.
Okay, wait a minute. I speak something. Rima?
Yes, sir. I'm here.
Yes, okay. So what we were studying in the previous class? Today is actually chemistry class, C2 chemistry. Yes, today we're going to discuss chemistry. Yesterday was also we are studying chemistry, na? Hmm? Okay. So wait a minute. In the previous batch we were studying. No, yes, I remember. So today's chemistry class for you. So we shall be discussing okay. It's just remove a minute. Okay. Okay, Reem. So we were discussing the is matter around us pure. Okay, let's start is matter around us pure. Okay, it's an important chapter that we have also studied in the previous classes, but let us start again. Okay, when you are going to have your exam of this chapter, Rima?
So I'm not going to school. I don't have any examination and all.
You're not going to have any examination yet right now, na?
Yes, sir.
Okay. Okay. So let's start studying this chapter, that is matter around us pure?
Okay, sir.
is matter around us pure? Okay.
Okay, sir.
So if I talk to you that what is matter, you know very well that matters on the basis of their physical properties. We have discussed the three types of matters: solid, liquid, and gas. Okay, now what we are going to discuss here is that matters is further divided into two parts. Okay, or we can say that we have divided matters into two parts. One is pure substance, and the second one is impure substance. Okay, impure substance. You understood? You remember this one? What are pure substances? We have further divided pure substance into two parts. One is elements, and the second one is compound. Okay, Eva, you understood?
Yes, sir.
Elements and compounds. And impure substance has been divided into one part, that is, we call it mixture. And further, these mixtures has been divided into three parts. First is two parts. One is heterogeneous. The second one is homogeneous. And heterogeneous mixtures is further divided into two parts: colloids and suspension. And homogeneous mixture is true solution only. True solution. Please copy this one, each and everything. Please copy this one. Okay, Alvina, what we are studying here right now is we are studying the is matter around us pure. Okay, so here
Okay.
we have written here that matter has been divided. Means in the first chapter, what we have studied that uh, matters has been divided on the basis of their physical properties of particles into three parts. One is solid, liquid, and gas. But here we have classified the matter on the basis of their chemical compositions. So we have divided the matter on the basis of chemical composition. So we have divided one into pure substance, that is elements, and the means pure substance and the impure substance. Pure substance are divided into two parts. One is element, another one is compound. Another one is compound. Okay, and impure substance, one is heterogeneous mixtures and homogeneous mixtures. Hence, impure substances are the mixtures, and one is heterogeneous and the one is homogeneous.
Yes,
Further,
sir.
the heterogeneous mixtures has been divided into colloids and suspension, and homogeneous consist of only true solution. So make this chart as soon as possible in your
Okay.
copy.
Son, then.
Okay. So wait for so that she can also make. Okay, take the screenshot for this one. Okay, because it will take more time. Alvina,
Okay.
can you take this? Can you take the screenshot? We'll make it. Okay.
Yeah.
Now
Done.
talking about the pure substance. What are pure substance? Pure. What does it means pure? When you think about pure means that there is not impurities are mixed. It is clear and crystal and clear. Okay. So if you have means if you have a glass of water that is distillery of means clear water. Okay, and if you add some sugar to it, a neat and clean sugar to it, will it become impure? Will it become impure?
Yes, sir.
Yes, it will become impure. But according to you, you can drink this one. Can you
Yeah.
drink impure substance? No, you can't. But
Mm.
here you can drink the impure substance. But so I can say that in chemistry, impure does not means that a good thing is added or a bad thing is added. Impure means that there are two substances are mixed together and that it's impure. They are physically bonded. Okay.
Okay.
Okay. So let me write a definition of this one. And you please note the definitions of pure and impure substance. Okay. Noted, Alvina.
Yes, sir, noted.
You left the
Yes, sir.
class. Again, you noted. How it is possible that you noted? You left the class, no?
Okay. Yes, sir, I don't know, sir, suddenly you got stuck in between. Now I completed quickly. I wrote it down.
This one, na? Okay.
Yeah.
So, what are pure substances that consist of only one kinds of atoms? That consist of only one kinds of atoms are called pure substance. Okay, and we can say that pure substances are those which consist of only one kinds of atoms, consist of one kinds of atoms or molecules. Okay, they are
Yes.
they are called pure substance. And impure substance, those substances that consist of more than one kinds of atoms or molecule, not chemically bonded, are called impure substance. And they are physically bonded. You can say that. Okay, so you have to keep in mind that
Okay.
not chemically bonded impure substance. An example, mixtures. Mixtures comes under this category. And for example, here elements and compound come under this category. Elements and compounds comes under this category. Okay, so let's discuss each and every one. What is the difference between an element and a compound? Let me explain. What is an element and what is a compound? So an element is anything that consists of only one kinds of atom. Okay. Okay,
Okay.
let me explain you that what is an element. You are very much familiar that you breathe oxygen. Okay,
Yeah.
so oxygen is an element. You have you see that car are made up of irons, aluminium. These are the
Yes.
elements. Okay, so
Okay.
what is an element? That hydrogen is an element. That hydrogen, okay, the atoms of hydrogen are like this, that only consist of one nucleus at the center and one electron in the first shell. The element of oxygen is just like the the two electron in the first shell and then six electron in the second shell. 1, 2, 3, 4, 5, 6. And the third is like I'm talking about the nitrogen. This is the 2 in the first shell and 5 in the second shell. 1, 2, 3, 4, 5, 6. Sorry, 5 in this. 5 in the second shell. 1, 2, 3, 4, 5. I'm right of 6. 5 in the second shell. This is 1, 2, 3, 4, 5. Okay, this is 2, 5. And this is nitrogen. This is oxygen. And this is hydrogen atom. Okay, understood?
Yes, sir.
And if I'm talking about the metals, like we have calcium. Calcium is going to have 2 electron in the first shell, then 8 electron, then 8 electron, and then 2. The it is going to have first 4 shells, such like 4 shells. Okay. So what
Yes.
I'm going to tell you here, that what is an element? An element is that substance that consists of only one kinds of atoms, and different elements have different kinds of elements. Sorry, atoms. For example, if you have taken the oxygen from here in India, so every oxygen atom is going to have this kinds of atoms. Okay, there is only one difference between the nitrogen and oxygen atom, that you can see that only of one electron. Nitrogen atom consists of 2, 5, and oxygen atom is 2, 6. Now you can see that the number of electrons, how the number of electrons plays important role. Nitrogen, you cannot inhale the nitrogen gas, you cannot survive with the nitrogen gas, but you can survive with oxygen gas, just because of one electron's difference.
Yes,
Okay.
sir.
So this is very important, that hydrogen gas burns in air, but if we have helium that is going to have 2 electrons in the first shell, it is noble gas, it does not burn. Helium never burns. Okay. So why the
Okay.
helium cannot burn and the hydrogen can burn? Because they are the 2 different elements. They have 2 different kinds of atoms. So different elements have different kinds of atoms. You understood?
Yes, sir.
Different elements have
Different atoms.
different kinds of atoms. Okay, so if I talk about what is an element, we can write the definition of elements. We cannot write the definition of elements. We can write an element. An element is a substance, substance that consists of only one kind of atom, only one kind of atoms. And different elements have different kinds of atom, No 2 elements can have same kinds of atom. Okay, no 2
Okay.
elements can have same kinds of atoms. If they have same kinds of atom, then it will be considered as single element, the same type of element. Okay, got it?
Okay, sir.
Different elements have different kinds of atoms. So now you understood that what
Yes,
is an
sir.
elements? Okay, and it is the element that consists of only one kinds of atoms. Okay. Okay, now moving to the next one is compound. What is compound? Compound. Okay. So compound is when 2 or more elements chemically combine together. When 2 or more element or atom chemically combine together, they form a compound. Okay. When 2 or more atoms chemically combine together, they form a compound. Now you understood what is a compound?
Yes, sir.
Let me explain you. Rima,
Yes,
you understood that what is a compound?
yes,
Let me
sir.
explain you. You understood that what is an element first? What is an
Yes, sir.
element? Okay, for
Yes.
example, if I'm talking, let me explain you. Like you have a strip of copper metal, another strip of gold metal, okay, another strip of silver metals. So the atoms of copper is different from gold, and atoms of gold is different from silver. So they are going to have billions of, means a very huge number of atoms, because atoms is very, very small. So even a tip of pin, if you have a tip of pin, it can have billions of atoms, billions raised to the power something. Okay, trillions of atoms. It can have trillions. Only a tip of pin can have trillions of atoms. Okay, so atoms is very, very small. So if I talk about this one, that this is atoms. If I'm talking about, this is gold, this is silver, this is gold, and this is copper. Okay, so they have different kinds of atoms. So and copper is an element. It consists of atoms. Silver is also an element. Gold is also an element. Okay, but atoms of golds are not same as that of silver, and atoms of silver is not same as that of copper and gold. Okay, so they have different elements, have different kinds of atoms. Now, when these elements are chemically combined together, they form a what? They form a compounds. Okay, chemically combined. For example, if I'm talking about this oxygen atom, okay, two in the first shell, 1, 2, 3, 4, 5, 6. Oxygen is going to have 2, 6, and hydrogen. Okay, now you
Yes, sir.
understood. Now, actually, when a chemical compound is formed, and what is the difference between a chemically bonded together and a physically bonded together? Let me explain you. For example, if you have a sugar solution, okay, like you have water, like we have water particles, like I'm just drawing this is water particles with this one. Okay, these are the water particles. And we add sugar to it. So this have intermolecular space, that we have the sugar to it. So we add sugar to it. So they're not making the physical bond. What they are doing actually, the sugar is going into the intermolecular space of this water. Okay, got it?
Yes,
So
sir.
here no new substance is formed. They are just going into the and sugar, you know that if you add sugar to water, you will feel the taste of sweetness. Okay.
Yeah.
If you add a lemon to it, you will feel the taste of sweetness as well as sour taste. If you add some salt to it, you will feel the taste of all three: salty, sweet, and sour. Okay. So they are just going
Yeah.
into the intermolecular space. So they are not showing I mean, they are still showing their property. Okay. You understood?
Okay.
But what would happen? What is going to happen here? You need to understand here one thing, that whenever chemically bonded to elements are chemically bonded, their electrons are exchanged. The electrons is being means the electrons of hydrogen can goes into the electrons of oxygen atoms, and electrons of oxygen atoms can comes into the atom of hydrogen. Okay,
Okay.
got it? Now you need to
Yes,
understand
sir.
one thing, that you know that water is made up of what?
Hydrogen and oxygen.
Hydrogen, oxygen. Do you feel that hydrogen shows the property of its hydrogen in the water? Hydrogen is a fuel. Can you burn the water because it consists of hydrogen? No.
No.
Can oxygen help in burning? So it is already means hydrogen is present, oxygen is present. So what there is in it is already, means oxygen is here, hydrogen is here. So hydrogen is a fuel, oxygen help in burning. So water can be a very good combustible substance. Okay, water can be a very good combustible substance because it is consisting of fuel and oxygen that is helping in burning. So it can be a very combustible substance. But what water does? Water is actually extinguishing fire. So why in water the hydrogen atoms and oxygen atoms are not showing their property? Any idea? In physical change, the element shows their property. Like you have this physical change, sugar will show their property, water will show its property. But here, why it is not showing? Because there is no electron exchange is taking place. And you know that
Okay.
I have seen that here, when the electrons are being exchanged, the element does not show its property. For example, only if one electron is added to this hydrogen atoms, it will not remain as a hydrogen atom. It will become helium. It will start showing the property of helium. Okay, got it. For example, the difference between the nitrogen and oxygen gases, only of one electron. If one electron from here jumps from oxygen jumps into this nitrogen atom, the nitrogen atom will start behaving as oxygen, and this will be start behaving as nitrogen because one electron is not left. Okay, there's 5 electrons. So this is the electrons. So when the electrons are sharing, electrons are participating. So do you think that hydrogen will remain hydrogen because if its electrons are being shared? No, because hydrogen need to be one. For hydrogen atoms, there should be one electron in the outer motion. If this electron is being shared with somewhere, so it will not show the property, because it is the property of hydrogen is due to its single electron. Property of helium is due to its 2 electron. Property of oxygen is due to its 6 electron, outer motion 6 electron. Property of nitrogen is due to its outermost 5 electrons. So if the number of electrons are exchanged or being changed, or it is being shared, then the element does not show their property. Okay, you understood?
Yes.
So in water
Okay.
molecule, hydrogen atoms and oxygen atoms are sharing their electron. They are bounded. So if I say that they are bounded, how? Because they are sharing their electrons. Like you can see here, like they are just sharing their electrons. Like this electron is being shared, this electron is being shared. So this is the water molecule formula, that is H2O. We have water molecule like this. This is OHH, H2O. Okay, so in water. Now this, since this is chemically bonded, and you know that since the atom is very, very small, so if 2 or 3 atoms chemically combine together, so will they, and they are not showing their properties separately. So we consider that this as a whole, as a particle, a new particle, and we call it molecule. What we call it? New particle called molecule. Okay. What is this? This is molecule. You understood what is molecule? Rima?
Can you explain one more time, sir?
Yeah. I'm going to explain you. What is molecule?
Sir, atoms and molecules are kind of similar, aren't they? They both are
Yeah.
tiny.
Yeah, both are tiny, but in atoms, atom is single one. For example, carbon
Okay.
atom or hydrogen atom. They are the 3 atoms in this water molecule, 2 of hydrogen and 1 of oxygen. But since the hydrogen atom is bonded with oxygen atom, chemically bonded, electrons are being exchanged. So now the hydrogen atom is not showing its property, oxygen atom is not showing its property. Okay. Now,
Okay.
as a whole, water, a new molecule. What is molecule? When 2 or more atoms chemically combine together, they form a molecule. The definition of compound and molecule is almost same. Okay. So here in
Okay.
a molecule, here you can say that in a molecule, the constituent of atom does not show their property. Okay.
Okay.
Okay. Like for example, the hydrogen atom is not showing, oxygen atom is not showing property. So this is considered, means you can see that if you have we just imagine that that hole, if you have a drop of water, okay, you can
Okay.
consider if you have, like you have taken 1 drop of water or 3 drop of water from the ocean,
Okay.
so can you consider that comparatively 1 drop of water or 3 drop of water, can you consider that this with the whole the water of the whole ocean, the
Okay.
3 drop of water will still be considered as a single particle? 1 drop of water in comparison to the water of the whole ocean. Even if you
Okay.
take a bucket of water, it will be considered as a single particle. This is very, very small as comparison to the water of the whole ocean.
Oh, okay, sir.
Okay. So that's why I'm saying that if 2 or more atoms are combined, like 2, 3, 4, 5 atoms are combined, they are combining and they have combined chemically. Their electrons are being exchanged. So we consider that this combination as a new particle. So H2O is very, very small. So as comparison to the size of because atom is very, very small. You know, if three atoms combine together, they still form a particle, because still this is H2 is very small in size. Okay.
Okay,
Okay.
sure. So, sir, molecule is a group of atoms, right?
Yeah, molecule is a group of
You
atoms,
can say that.
and it
Yeah.
is considered to be as a new particle. Okay.
Okay.
So what I'm saying here is that what is a molecule? Let me explain you that we have discussed here. That compounds in compound two or more atoms or element. You can write here elements, two or more elements. Elements means like carbon element, oxygen element. Okay. So this is for writing the definition of compound, we write two or more element combined together to form a compound. Chemically combined together form a compound. And if I write the definition of a molecule, so what I write here is when two or more atom chemically combine together, they form a molecule. You understood? What
Yes,
is
sir.
the difference between a molecule and compound? Here we write here atom, then it will be a molecule. If we write instead of atoms as element, then it will be a compound. Okay.
Okay.
Okay. So there is a difference of one word. Okay, that is atoms. If it is atom, two or more atom chemically combined together, they form a molecule. Otherwise, it is okay. Now you understood, everybody in the class?
Yes, sir.
Should I move forward? Rima, you understood?
Yes, sir.
Okay. Now talking about this one, let me explain you. Molecule when two or more atoms chemically combined together they form molecule. Okay. Now we have discussed the elements, we have discussed the compounds. For example, if I ask you that calcium carbonate, CaCO, no, calcium. I'm asking carbon dioxide. Is it a compound or a molecule?
It's a compound.
Yes, it is a compound. And CO2 is a molecule. Okay. So this is a compound. Okay. So compound and it is molecule. Okay. Let me explain you one more thing here, that there are two types of molecules. If the same element combined together, they form homoatomic molecule. Homoatomic molecule and heteroatomic molecule. Heteroatomic molecule. So write a definition. I will be coming that what is homoatomic molecule and what is heteroatomic molecule. If the two or more same kinds of atom combined together, they form a homoatomic molecule. And if the two or more different kinds of atom combined together, they form a heteroatomic molecule. Note it down. Done?
Sir, can you say it one more time? Homoatomic.
Go. Note it down. When two or more same kinds of atom combined together, they form a homoatomic molecule. Homoatomic molecule. For example, H and H when combined together, they form H2, O2. Okay. Okay. Hydrogen.
Okay.
And heteroatomic molecules means when two or more different kinds of atom. When two or more different kinds of atom when two or more different kinds of atom combine together, they form heteroatomic molecules. Okay, note it down.
Sir, what are the examples of heteroatomic molecules?
Like we have H2O, hydrogen and oxygen, two different elements are there.
Okay.
Okay, like we have carbon dioxide, like we have ammonia NH3, etc.
Okay, sir.
Rima, you understood? Rima,
Yes, sir, I understand.
okay. Let's move
Finish.
further. Finished? Okay, wait a minute. Okay. For example, if we have this one, okay. Hmm. Let you have this one. Let me correct you. Understood each and everything. What is mixture, homogeneous mixture, heterogeneous mixture? We will discuss this one later. Okay. First of all, we are just discussing the compounds and elements. Okay.
Okay, sir.
So here we are discussing compound and mixtures. Okay. Compound and mixtures. What is the difference between compound and mixtures? So you know that in compounds, elements are combined together with chemical bonds. Okay. And the new substance is formed. And moreover, the in mixtures, the particles of the substance show their property. Okay. So here we have elements or compounds are simply mixed in mixtures. Okay. To form a no new substance is formed. And as a substance are reacted together with each other and form new substance. Okay, so note these 2 or 3 points here. Note these points.
Okay, sir.
Then I'm going to explain each and every one. Okay.
Okay.
Done.
Not yet.
Yes, sir.
So you know that in mixtures no new substance is formed, but in compounds new substance is formed, because like in water, water is a new substance having its own property. It does not resemble the property of hydrogen and oxygen. So this is the meaning of the first statement. Element do not combine in a fixed ratio. You know that in if you are making a mixtures. So let me explain you the second point here, that if you are making a mixture, so it does not mean that you need to make this one in a simple ratio. Okay, like for example, if you are having a glass of water, if you add 1 tablespoon of sugar, then it will also a sugar syrup, okay, solution. And if you have two
Okay.
tablespoon of sugar, then it is still a sugar solution. It will not become something other. Okay, but in compounds, elements are combined together in a fixed ratio of mass. And there is H2O, there will be always two hydrogen atoms and one oxygen atom chemically combined together. They will form one water molecule. So it is not possible for means we cannot change. We cannot say the water. No, the Indian water is H2O, the American water is H3O, and the UAE water is H3O or O4. No, this is not same. If I'm talking about water, wherever, irrespective of irrespective of their location. If I'm talking about water, if water is found in USA, in America, or anywhere in the whole universe, if it is on the moon, then it must have the same composition, that is H2O, means two hydrogen atom and one oxygen atoms will combine together, they form a one water molecule, and this ratio is fixed. So in a mixture, there is no fixed ratio. We don't have to prepare when if you are making a cup of tea. So we need not to make them like if we add 2 tablespoons of sugar and 1 tablespoon of tea, then it is also a tea. If we add 1 tablespoon of sugar and 1 tablespoon of tea, then it is also a tea. If you have half tablespoon of sugar, half tablespoon of tea, then we don't have any fixed ratio for this one. Okay. So this is called
Okay.
this is a mixtures, but in mixtures in compounds we have the fixed composition. Like for example, if I'm talking about carbon dioxide CO2, so in carbon dioxide, one carbon atom and two oxygen atoms are going to make carbon dioxide. Okay, you cannot say there's two carbon atoms and three oxygen atoms are going to make carbon dioxide. No, it is not so. Okay, carbon dioxide is CO2. This is fixed, one carbon and two oxygen atoms, fixed ratio. Okay.
Okay, sir.
And moreover, we don't have any fixed formula for the sugar solution. Like we don't have formula for the sugar solution, but we have the formula for the water. We have the formula for the carbon dioxide. We have the formula for ammonia gas. We have the formula for the means the acid like HCl, hydrochloric acid. Okay, so we have the formula for this one because these are the compounds. And compounds have the fixed formula. Okay, you understood?
Yes, sir. Yes.
So here the element do not combine in fixed ratio, but here the composition of the elements is fixed. They combine together in a fixed ratio according to their masses. Okay, got it?
Yes, sir.
A mixture show their property of the components, means mixtures after the change it show the property of the component. For example, if you are having a mixture of sugar solution or salt solution, so still you can feel the taste of salty. When you drink the salt water, then you can feel the taste of saltness. Okay, so they are showing the property after the change because the particle is going into the intermolecular space, not it is the electron exchange is not taking place. And whenever the
Yes, sir.
electron exchange is taking place, a new substance is formed. It does not resemble the property of the previous one. So here in compound does not show the property of the components, the third point of the component, or you can write constituents. Okay. Component can be easily separated. You know that they can be easily because they are physically bonded, so they can be easily separated out by simple evaporation, by simple distillation, filtration, okay, centrifugation. So they can be easily separated by simple physical methods. But
Yes, sir.
you cannot separate the hydrogen from the water by simple filtration, evaporation. If you heat the water, it will get converted into steam, but it is still water. If you freeze the water, it will become ice, but it is still water, H2O. It does not become H3O5 and something, hydrogen, oxygen are being separated. So they cannot be easily separated by simple physical method like evaporation, filtration, distillation. Okay, got it?
Yes, sir.
So if I'm, for example, if mixture of iron and sulfur is mixed, they are mixed together, it will be considered as mixture. That's not just mixing iron nail with sulfur. But if you heat the mixture of iron and sulfur, then they will form compound. Okay, if you heat a state, iron and sulfur react to form iron sulfide. So iron sulfide is a compound. Okay, Got it?
Yes, sir.
So write down the fourth point also.
Finished, sir.
Finished? Okay, very good. So let's move further. Let's talk about now you know that there's simple physical change and chemical change. The changes which is not reversible, that is called chemical change. Reversible is called physical change. New product is formed, no new product is formed. So this is you can do this. So let me discuss the important thing that is mixtures. Okay, let's talk about the mixtures. Wait, let's talk about the mixtures. What are mixtures? Tell me what are mixtures? You know that you have written that mixtures, the definition recently. Mixtures are the homogeneous
Elements or compounds which are simply mixed to
yes, they called
where no,
mixtures.
yeah,
So when two
where
or
no
a
new
two
substance is formed.
yeah, no, not in a fixed proportion, they called it mixtures. So you have done this one. Now moving towards this one, that how a mixture is formed. The definition is done. When a solute is mixed with solvent, if they form a solution. Okay, and what is solute? What is solute? Solute and solvent and solution. Actually, the state of the solution is considered to same as that of solvent. For example, if I'm having water and sugar, water and sugar. So you know that sugar is solid and water is liquid, and you have sugar solution as a solution, sugar solution. So you know that sugar solution is liquid. So actually, if sugar solution is liquid, so whatever is the liquid is the solvent. So water is the liquid, so it is solvent. Okay. Now you understood?
Okay. Yes,
So
sir.
if I ask you that it is sodium, which is solid, plus that is mercury, okay, that is liquid. And when they are mixed together, they form sodium amalgam, and that is also solid. So which one is solvent here?
Mercury is the solvent
Why mercury?
because it's liquid.
No, every liquid is not solvent. You have to check the state of the solution. If the solution is solid, so whatever is solid is solvent. So here it is solvent. Sodium is solvent. This is solvent, and this is
Solute.
solute. Okay. The state of solution and solvent is same. Okay, you understood?
Okay, sir.
The state of solution and solvent is same. Okay, understood?
Okay, sir.
Now, talking about the types of solution, we have different types of solution. One is homogeneous mixtures, another one is heterogeneous mixtures. Okay, so let's talk about this one here. Homogeneous mixtures are those mixtures, types of mixtures we are talking about. Okay, so note the definition that homogeneous mixtures means those mixtures in which has a uniform composition, and this solution, in the solution the particles is completely in the intermolecular space, and we can say that we cannot see the size particles. Okay, this is very small. Okay, so we can say that it has no visible boundaries for separation between the various constituents, so they are called the homogeneous mixtures. Note the definition. Note the definition
Okay,
of
sir.
homogeneous mixtures.
Okay, sir.
You too, Rima. Rima, are you there?
Okay, sir.
Okay.
Yes, I'm here.
Noted.
Thank you.
Finished, sir.
And everybody, okay. So homogeneous mixtures and heterogeneous mixtures means there is a mixture that has visible boundaries, means you can see the particles of but we can say that almost the particle is visible. Okay, if it is not visible, then it can be easily the particles settle down. If it is not settled down, we'll discuss this one. But in heterogeneous mixtures, what is going to happen is the particles or the mixtures have visible boundaries, and then they can be separated into its constituent. Okay, like the mixture of sand, sugar, and does not have uniform composition throughout the solution. Okay, note it down. Write down the definition of heterogeneous mixtures also.
Okay, sir.
Done, sir.
Done, everybody?
Yes, sir.
Noted, Dima.
Yes, I'm here.
Done. So that's all for
Yes.
today. We'll discuss the next topic, that is colloidal solution, suspension, heterogeneous mixtures, and the different types of the difference between these. Okay, that we're going to discuss in the next class. Okay, so that's all for today. We'll meet you in the next one. Okay.